Hello, and welcome to the Laney College Photo Department's presentation on light, color, and correction. Light has color? Yes, it does. I know it looks white, but it's really made up of a full spectrum of visible light. Now, what you see here is a graph that describes very low frequency emissions, radio emissions, to very high frequency emissions, cosmic rays and gamma rays. We actually see only a very narrow portion of it, what we call visible light, from violet to red. We don't see infrared, we don't see ultraviolet. Some animals do. But this kind of a spectrum is a function of what they call black body radiation. I know it's a little sciencey, but we're good. Here's black spring steel. Slowly, as it's heated up, it starts to emit a color, red wavelengths, lower frequency wavelengths. As it gets hotter and hotter, the higher frequency wavelengths start to occur in the orange, higher yet in the yellow, higher yet in the whites. This is another kind of light experience. This is a function of diffraction. The sun has hit the atmosphere, notably droplets of water, and these little droplets of water, these little microprisms, micro lenses are splitting up light into its constituent colors. And here we have red, orange, yellow, green, blue, indigo, and violet. This is a function of a black body source emitting a full spectrum of light that ends up looking white, that is split up into its constituent colors. This is more a function of filtration. That is, when the sun can just shine through a clear atmosphere, the light is pretty true to white. But the more it goes through more layers of atmosphere, longer aspects of the atmosphere, dust, particles, or water, the higher frequencies get blocked, and the lower frequencies, the red frequencies, just as in the spring steel, get to show up. The higher frequencies get blocked by all the particles and the water. The lower frequencies can manage their way through. The best analogy is the foghorn. The very deep tones of the foghorn are able to execute their way through all the particles in the fog and be heard at great distances. That's why the foghorn is so deep. The other thing that you'll notice is when you're sitting in fog, it feels like it's a whole lot more quiet. Well, a lot of the higher frequency sounds are simply being blocked out. By analogy, the higher frequency colors are being blocked out and only the lower frequencies come through. How do we manage this? Well, we use auto white balance, or we use dedicated settings, dedicated presets. And you can find these presets in various parts of your camera. You may have a command dial here with a white balance button. You may have a similar button someplace else on the camera. You may have a button you can press on your LCD if it's a touch screen, or you can go into your menus. But that's where you will find the presets. Now, these presets are generally represented by these kinds of symbols. They're pretty close in all cameras. And I want you to look at this. Here's the incandescent. And the incandescent light, the light bulb can be orange. Direct sunlight, pretty clean. Cloudy, a little blue. In the shade, a whole lot blue. We're not going to talk about these for now. In order to balance the incandescent bulb, we have to have a bluish filter, and these will neutralize the incandescence to something more acceptable in terms of whiteness. If we just use a neutral direct sunlight preset, it does not affect the direct sunlight. If we're working in a cloudy day, we're going to add the cloudy preset, which, as you can see, is just a little bit on the yellow side. And when it's really, really, really blue in the shade, we add a shade preset, which is a little yellow and a little red to neutralize that color. And here is a nice graph that shows you the symbols, the tungsten bulb, when photographing in homes lit by artificial light to add cooler tones to compensate for too many orange-yellow hues. And each one of these descriptions talks about what you're using and why and what your result will be. This down here, custom white balance, whole different thing later in the year. This is window light. This window light is bluish and it's not particularly flattering. It brings out the redness in Andrea's face, which she doesn't have. This is window light, color corrected. And you can see the trueness of all the colors. Look at that green. Check out the rich wood color, the light green in the good china, the cream color. Look at the light that bounces off of this right here and makes a little bit of red, right? Beautiful red leather. Nice true blue, no weird casts. And look at the skin tone, the lovely skin tone. Look at the nails. That's a real nail color. Good turquoise. She's just a slightly bit of rosy. She's very fair. And look at all the colors in her blonde hair. You wouldn't see those if the color balance wasn't right. And this is your basic portrait. It looks like nothing when you look at it. But boy, look at all the different beautiful colors in this man's skin. The reds, the flesh tones, the sort of 5 o'clock shadowness. Look at the whites in the shirt are so true. Look at the salt and pepper gray in his hair. All these subtle colors do not come out unless you have good white balance. This, fireflies in a jar. How do you balance that? I have no idea. The world-renowned Laney Photography Department thanks you for your kind attention.